Hello everyone. In this second tutorial, we introduce multivariable regression using the linear support vector regression algorithm, or LinearSVR. This technique is used to model a continuous target variable, such as vehicles' fuel consumptions, based on multi-input features, including engine specifications and other metrics. LinearSVR builds a linear predictive function while tolerating small deviations within a defined epsilon margin, making it robust against minor data fluctuations. The goal of this tutorial is to demonstrate how Scikon enables intuitive exploration of machine learning models, from data ingestion and feature preprocessing to model training, prediction, and performance evaluation, all within a user-friendly interface. Multivariable regression is a statistical technique that models the relationship between a single continuous dependent variable and multi-independent variables. This approach enables us to understand how different features jointly influence the outcome, while controlling for the effects of others. Unlike linear regression, which assumes a one-to-one relationship, multivariable regression allows for more realistic modeling of complex systems. It is particularly useful in applied domains, where many factors such as engine parameters and efficiency contribute simultaneously to output, like average fuel consumption. The dataset used in this project is based on Canadian vehicle data and has been pre-processed for regression modeling. It includes several key attributes: model year, make, model ID, and vehicle class, all of which have been numerically encoded. Technical specifications such as engine size in liters, number of cylinders, and transmission types are included. Fuel characteristics are captured through columns like fuel type, city, and highway fuel consumption. The target variable, combined fuel consumption, provides a quantifiable environmental impact measure, making it a practical outcome for regression analysis. The dataset contains 1,068 samples with 12 selected features for training, since machine learning models operate on numerical data. All categorical string features such as manufacturing, vehicle class, and transmission type have been encoded as integers. The cleaned and transformed dataset now supports efficient training with models like LinearSVR, which benefits from dense numerical inputs for faster optimization and accurate prediction. This is the example of the dataset after encoding. The make, model, and vehicle class have been numerically converted to integers. LinearSVR is a scalable implementation of support vector regression that fits a linear model by minimizing a regularized epsilon insensitive loss function. This approach tolerates prediction errors within a small threshold epsilon, which helps reduce sensitivity to noise. It solves the optimization problem using a coordinate descent algorithm from the linear library, allowing it to scale efficiently to large dataset. The regularization strength is controlled by hyperparameter C, balancing the model's generalization against fitting accuracy. This makes LinearSVR a very powerful tool for continuous output prediction in high-dimensional feature spaces. We will reserve 80% of the input data for training and 20% for model prediction as test data. We use R-squared evaluation metric to evaluate the performance of the model. With higher R-squared value means higher accuracy of the prediction. Now let's move on to the implementation of the machine learning method in Scikon. First, let's give a name of our project. Second, let's write a brief summary of our project in the description section. And then, in the data section, let's choose tabular data. And then let's click this button to choose this dataset. After successfully uploading this dataset, we can see the data overview on this tab. And then we can also see the data summary on the data tab. So the data summary includes 3 types: the new instances, data types, and unique values. Next, let's choose our target column, which is the last one, film consumption combined. And then let's choose our machine learning method. Let's choose our LinearSVR regression model. And last, let's choose our evaluation metric R². And then we click Perform. Now, the R² score is 0.94. It means our model was able to accurately predict the result. If we scroll down to the tables section, we can see, and scroll to the right side, we can see the y-test and y-predict columns. The y-test column is the actual ground truth of our data, and y-predict is the predicted values. As we can see, the y-predicted values are very close to y-test values, which means our model is able to accurately predict our result. And this has been our tutorial for LinearSVR model. Thanks for watching.